and how you submit your homeworks. Today we will finish up with HTML and CSS, then do a little bit of SVG, which is of course important for your homeworks. And then we will start looking at JavaScript. And hopefully, if we get everything in by today, at the end of the day, you will be able to write a program in JavaScript like you are, for example, in Python or C or whatever. Okay, so one of the key elements of HTML is the DOM. I just wanted to reiterate that, how important it is, and you can always access it with the web developer tools, the developer tools in Chrome, for example. And here a key concept is that the DOM, as it's rendered by the browser, is not the same thing as the sources. Like you can write, and we will write, a lot of code that generates the DOM dynamically. What you see here is actually like what is generated and what is actually rendered. So here you can look at the DOM as it is rendered in the browser, but here you can look at the sources. So these two things are different. And you can see here, like this is the website code, and there's a lot of JavaScript in the website code, which you don't see in the DOM. Okay. So then we started to talk about CSS, and I mentioned that CSS are like, they're called cascading style sheets, and they're really there to style your code. And the idea behind that is that you separate like the content and like the organization and the logic of any documents from the presentation. And so you could, for example, develop a mobile version of your website, or you could make it accessible to blind people and so on. So a key concept for CSS are, of course, selectors. So here we have a very simple CSS rule. Like we have the strong element, and we are kind of selecting on the strong element in CSS. Like we saw that, we talked about this last time, the style can be either in a separate file, but here in the class we will typically use this embedded in the HTML file just to make it easier to understand all the relationships. So here we have set like all the strong elements have a background color of red and a font size of 300%. And then we can see like this part here is strong, and this matches, the selection matches, because it's the same element. So if we add a second strong element here, then we see that it's immediately also in red. Okay, that works for multiple cases, and then we kind of stopped when you started talking about class selectors. In class selectors, there's like three types of selectors. There's ID selectors, class selectors, and element selectors. We've talked now about element selectors, which select an element, but they're typically not very helpful. But because once you write a little bit more complicated websites, you're reusing your standard tags for multiple purposes. So instead you should use class and ID selectors. And the class selectors, they're marked up with this dot at the beginning. So like here I am saying dot important. And here the string, like whatever I put here, like in the case of elements, this was defined for me. But here I have the liberty to use whatever I want. And then I have like the important, and then I have footnote. And here we see the div with important and footnote. So this is how you identify an HTML element as being of the class, and you can have multiple of those, and then you can see like some text is bold and footnote is not bold. And then we have another important footnote, like an important footnote, and we could equally add another one. So we can always reuse this many times, and that's the idea of classes. Okay. And of course the name here is arbitrary, so I could put in whatever I like. It should be some meaningful variable name, it shouldn't be something short, just because of good software engineering practices. But this is completely up to you, what you want to put here. And the ID selectors are very much similar to class selectors, with the one big difference that you must only use them once on your website. So like ID is supposed to be really a uniquely identifying element, attribute for an element. And you can also use it to anchor your website. So if you put, like this is how they look like. They have this hashtag first line, hashtag second line, hashtag important. And if you were to put like the URL and then hashtag first line, the browser would automatically scroll to this line here. So before, like in the earlier days of HTML, that was used with anchor tags, but nowadays this is used with IDs. And IDs are also very important because they kind of uniquely identify the elements. So we will be using a lot of IDs and classes. So this here is maybe not such a great example. This is a better example for a class because like important, we could imagine that there's multiple important things, but just for the purpose of demonstrating the code, that works too. And we can see here we have a text shadow on the important one, and we have blue on the first line, and some increased font size on the second line. You may also use a combination of IDs and CSS to create a layout of a page. So like back in the old days, people used either iframes or tables to produce layouts on websites. Nowadays you should use CSS for the reasons that I mentioned. Like you can dynamically react to any environment that you're in with CSS. So what I'm doing here is creating a basic layout. And you can see like I have a sidebar, a main, and a footer. And like here I'm defining the width and the height. And the width is relative, the height is absolute in pixels. Then this is floating on the left, and I'm just giving it a background color so that you can see something. Then we have a main, like the main window, with a width of 70%, the height of 200 pixels, floating on the right, and the background color again. And then a footer that has that is 100% width and another background color. And then here, what I'm doing is I'm using like a little bit more modern elements. So the nav is very similar to a div. The only difference is that it's simply called nav just to give you some semantics when you write the code. So it's supposed to be the element that contains the navigation element, because otherwise you will always have divs and it's hard to read and hard to parse. And then similar to that, you have a main element. So instead of using a div, you can use the main element. It works exactly the same way, but you can simply, it makes it more readable, and then you have a footer. So there's a couple of those elements now in HTML5, like article or heading and so on, that make it easier to structure your code and then to read it. So this is how that looks like. So we have the menu here on the left, we have the main part on the right, and we have the footer here at the bottom. And this is just like, of course, very rough, there's no padding and so on. All of that you can do, you can add, but this is kind of the basics how you can use CSS to create layouts. Okay. So instead of just doing selections based on individual items, elements, or IDs or classes, you can do also combinations. So you can use a child selector here. Like this here means that all of, like we have the pair, like this is an element selector. It matches all of the bold elements that are within the paragraph. So like it's a parent-child relationship here. But it's only exactly when there's a bold element within the paragraph. So we can see here that when we have a bold element within a paragraph, we get blue color, and we can see, okay, here's the blue color, and that's because here it's a paragraph, and then we have bold within it. So like this is this child relationship. And then we have a descendant selector, which is more liberal. So in this case, if there is like a P, then a span, and then a bold, that wouldn't match. But in this case, where we just have this descendant selector, any combination, no matter what the hierarchy is, like I could have a div, a span, a paragraph, and then a bold, and this selector here would still match. So here we can see an example for that. So here's a paragraph, here's a span, here's a bold. No, that's not this example. Here's this example. So there's a div. This is the top level element that we're matching for here. Then we have a span, which is the second level, and then we have a bold. So the child selector wouldn't match, but the descendant selector does indeed match. And then we would see the color green here for this bold text. Any questions about that? Okay. Instead of doing these inline definitions of CSS that we're doing here, you should, in like a real project, you should put it into a separate file, because you might want to reuse your styles across multiple files, and you want to centrally define them in some file. And this is how you include them in the header, within the head element. And then you can also place CSS circulation directly inside an element. So here I am actually styling this inline. As you can see here, so this text is blue. This is okay for debugging, and this is maybe okay if you automatically generate it. But if you write plain HTML, you shouldn't use that too much. Like if it's a one-shot thing, you might think about it, but it's probably gonna come back and bite you at some point. Okay, so this is CSS. There's of course much more to CSS. There's now languages on top of ESS like Sass, where you can use variables and where you can use inheritance and so on. But for like the basics that you will need in this class, that should be fine. So now let's talk about SVG. Okay, so SVG for now looks quite familiar. We embed it within an HTML elements, and then we start like SVG. We define a width and a height here for the SVG element. And in this case, this is kind of the minimal definition of an SVG, which is just a blank canvas. Oops. A word on the coordinate system of SVG. So what happens in SVG if you start with homework 0, homework 1, this has already become apparent to you, is that like we're starting here at the top left. So if we increase any y values, it's getting bigger, like pointing downwards. Like this would be like 1, this would be 2, 3, 4, and so on. And that can sometimes be a little bit annoying because typically like computer graphics people think like that, but most other people think like starting 0 at the bottom. So this is just something to be aware of. And it's also like part of the homework, of course. Okay, so a simple circle. We again define the SVG with width and height, and then we define the x position, the y position of the circle, and the radius. And then we use something very similar to CSS, but you will see that it's not exactly CSS. Like the syntax is the same, but the elements that you can use are different, the style elements for SVG. So you have to look them up. They're different, and some of the IDEs will complain that this is not a valid CSS syntax and so on. So just like stroke width and so on, like these are the SVG specific things. And so you can see like we have defined the circle and we have defined its style. And we could equally change its style to blue, and we could immediately see that, and stroke, we could say black, and so on. And by the way, you have quite a bit of named colors in SVG and CSS, so you could do steel blue, and so on. So this looks a little bit nicer, and you can vary things like stroke width here, pretty obvious. An ellipse works similar to the circle. In this case, you, however, define the position and Rex and Ry. So you can see the ellipse here, and we can modify it again, like make it into a circle, or make it even thinner. Anything here is possible. Again, same type of styling. Rectangles are important. We will be using quite a bit of rectangles. Works the same. We have rectangle, X position, Y position, width and height. And you can see like the fill, stroke, and so on. We can again modify it, but nothing super surprising here. For lines, we define a start point and an end point. So we have an x1 and a y1, and then we have an x2 and a y2. And the line is connecting between those two points. And we can modify that, of course, and say like 250. And we can see how the line changes. And in this case, I've not used inline styling, but I've used the styling here in a style sheet. And the reason for that is that I'm using, I guess, as soon as I'm using more than one element that uses the same style, you should always use like something centrally defined. You can also, yes?
If we ever put the style sheet in a separate file, will that confuse grading?
No.
Okay.
It's like typically for the larger projects we will be doing, you will be asked to do that actually. So as long as it works, it's fine. We might do like, some specific directions, but typically this is obvious. Like we'll see the link at the beginning of the HTML file, and we can go there. Okay, so you can render text. Not surprising, but you will actually need this quite a bit because labels are of course also important in visualizations. And yeah, you can specify X and Y position and then the text. So again, not very surprising. The path element is a little bit more complicated. So what the path element does is here you can see like a simple path element, or yeah, a medium simple path element. And I've just added like these two circles at the bottom to illustrate something, but let's talk about just this path element for now. So the path element lets you draw curves. And it has a couple of different types how it can render the curves. Like typically, like if you just want to do lines, polylines, like we have here, then that's of course obvious. But then if you want to use curves, you can use different kinds of curves. And so in this case, we are using the cubic curve. There is another type of curve. You can simply look it up in the Mozilla path tutorial if you're interested in and learning more about that. So how that works is that if you just want to do a polyline, there's two commands for lines. So there is this move, this M, and then this tells me essentially move my imaginary pen to the position 10, 10, but don't stroke. Like this M just tells us no stroke. So if we modify this to the L, in contrast to that is a stroke. So let's change this to L, and it breaks. It shouldn't. Well, we can see the other way around. So if we say, okay, like we're starting at the point 0, we're moving to point 10, 10, then we're moving to point 50, 10. So this is always relative to your previous point. So I'm moving in, I'm putting back L here. So here that means like go 50 right, go 10 down, and so on. And this is how you can create this kind of lines. Okay, and then we have the circle element, and the circle, not the circle element, but the polyline element. And here you need to specify control points, multiple control points. So in this case, I've specified 150, 50, 150, 50, and 150, 10. And if I modify those, and you can see like the points down here, like here is 150, 50, the first point, and the other one is at 150, 10. So this is 150, 50. And if we modify those, we can get a feeling of what this actually does. So we can see, okay, this goes around like towards this point, but uses an interpolation, so it's still a spline. So this is how you can draw curves. You won't have to do that a lot because D3 has nice methods where you can actually don't have to modify these kind of paths, but you will have to do it in the homeworks. So one thing that I think is said wrongly, it's not relative to where you were before, but it's actually absolute coordinates all the time. Any questions about that? Yes?
When you have your style broken out, is that something that we could do inline, or would you want us to define a class or something in CSS? And
For this one here?
Yeah.
So this is a case where I have only a single path. In your homework, you're doing multiple paths. So again, I would use a CSS style, a CSS or a global definition. So, okay. Great. So one thing that is important in SVG and every time you work with a graphics library is the ordering of elements, because it's going to determine visibility. It's important to note that here I'm drawing like an ellipse and a rectangle, and which of them is displayed on top depends on which of them is drawn first. Like here is the rectangle on top, so I'm drawing the ellipse first, and then I'm drawing the rectangle, and if I do it the other way around, the ellipse is on top. So pretty obvious, but this is something that is sometimes hard to, like if you create a more complex visualization, you have to think about layers, how you would layer your visualization, the things still come up on top. And that's also a common source of confusion, like if you work with a little bit more complex stuff. Okay, the last thing or one of the last things in SVG that we need to talk about is grouping. And you will also need grouping in your homework. So grouping is very powerful because it lets us do some higher level things. Like it lets us define elements of a certain class that we can move and around or modify together. So here we have just like a couple of circles. And if we wanted to like flip that around, for example, to use like a coordinate system that is not top down but bottom up, then we can simply do that with a big group. So here we have a group that does a transform, and a transform is also a very important attribute here. And in this case, we're translating it by 200 and then scaling it so that it's flipped over. So we can see now that this looks very much the same, but it's just flipped over. And now if you use this kind of transform, you suddenly have a coordinate system that starts at 0 at the bottom. You could also style, like you can always apply in SVG, you can apply a style at larger levels. So if you say, like, if you define, I didn't define a style here, let's say,
Style spelled wrong.
sorry?
Style spelled wrong.
Oh. So we can see we don't have to style the circles individually, we can just style the group. We could even style the SVG, but we can always, like, the style is, you can apply the style to the top level element. Of course, different approach would be that we have here class is circle, and then use like a central definition of circle. But in this case, it's a little bit more work to actually do it like this. And you will also use groups, for example, to move them around together, to interact, and so on. So groups are a very important concept. One of the problems of transformations is that they are great for shapes, but of course for text they're a little bit tricky. So like if you just do the same thing with text here, and you want to position text in the same way, it's flipped around. So we will learn how to deal with this kind of thing in D3 later. Okay, so that concludes the SVG introduction. Any questions about SVG itself? Any questions about the homework so far? Great, so we're moving on to JavaScript then. And you can, again, go along, it's on the website, there's this interactive JavaScript introduction. Okay, so JavaScript is kind of a language that has been around for a while now. Like your name would make you believe that it's somehow related to Java. The only reason why it's called JavaScript is because Java was like really hot at the time when JavaScript was developed, and they kind of wanted to use the buzz for the language. It's been developed by the Netscape people back in the day, and it's a mixture of many different programming paradigms. So we will see that we're mixing here like object-oriented programming, imperative procedural programming, and functional programming styles. So if you've used Java or C or maybe Python, these the object-oriented things will be familiar to you. If you like to use Haskell, you will find functional concepts interesting for you. And JavaScript has a couple of great features, but it has also some of the some more bizarre features. And you shouldn't, like in if you look for some solutions on the web, many of them are bad. So like it's not easy to find good JavaScript code. We will try to focus on the good parts, and there's also this nice book that you could read if you're interested in a little bit more, as I call JavaScript, the good parts. So the point of JavaScript is, of course, that you want to create dynamic content on websites. You want to have things move around, you want to have things react to user input and so on. And a couple of years ago, you essentially had a couple of options. So you could use Java applets, or you could use Flash, and so on. But nowadays, all of these technologies are dead, and JavaScript essentially reigns supreme in the web. So you don't really, if you want to develop for the web, you don't really have a lot of choice other than learning JavaScript. Okay. Two important things about JavaScript is that it is a dynamically typed language, so we don't have static types like integers or floats and so on, as we have them in classical object-oriented programming languages like C or C, like C++ or Java or even like C. And even though it's you can do object-oriented programming with JavaScript, it doesn't have a class system. So you don't have like a central class definition, but you use prototypical inheritance. So what that means is that you, instead of like saying my object is an instance of class A, or whereas class A could be like the child of another class, so that's how you would realize inheritance, you say my object has a prototype which is another object, and then it has the features of this prototype object. So I'll give you an example later, but this is just like the general introduction to the language. So we'll start with the very basics, and here in this case this tutorial is like written that you simply should open up your console, your JavaScript console at the bottom, and there you will see the output that is produced by all of these code boxes. So yeah, I'm starting with, like, it's probably not the most important feature, but it's the feature that we will be using a lot to see what is going on. So I could simply console.log text. Okay. And then at the very bottom here, I will clear the console. And then we get new text. So we get message, we get 3.14, like an approximation of P, we get the library value of P, and then we get what I added here. So just like a word of, a comment on how to use this if you want to play around. This has a delay in it, so about like 1 second after you stop typing, it will actually run the JavaScript code. If you like pause, like if I do something that doesn't make sense, you will get an error message. So I might at some time add a button here, but we'll see. And you can always clean the JavaScript console here, or clear the console if you just want to get like a fresh start. And you can add and type in here, and that should work fine. Okay, so that's pretty simple. Then, of course, as in every programming language, we have variables that can hold values. So here we're defining an integer. However, JavaScript doesn't distinguish between different types of numbers. So we don't have a difference between shorts, integers, floats, or doubles. We just have one number object, and everything is internally held as a number. So there's no difference. Like you don't have to worry about arithmetic. If you divide by, if you divide an integer and so on, you will actually get the correct results. You can, of course, use strings. There's no characters in JavaScript, so like if you would need a character, just use a strength of length 1. And I can, of course, strings can be arbitrary text and pretty long. There's a technical limitation, but it's you're not going to encounter it probably. You can define arrays. Unfortunately, arrays can be of mixed type. So you can have like a number, a string, and then another array nested within an array. There's booleans. We can have f, false, or true. And one of the other things that is a little bit annoying is that you can redefine any of the variables to a different type. So if I have like here defined f as a boolean, somebody else, maybe like you're using a library, and then you could redefine any of the variables to a different type, which will of course break things. JavaScript has another annoying feature that is called, like, it works a lot with global scope. So this is probably one of the most error-prone things in JavaScript, that you always have a lot of things hanging around in global scope. So we will be talking a lot about how we can avoid this. And one of the things that is important is that we can define local variables. Like here, all of these are global variables, and we can actually look at these. We can actually print all of these in the global scope, but we can define local variables using the var keyword. In this case, however, it's still a global variable because this only applies when it's inside the scope of a function. So I'll talk about functions later, but this is how you define local variables. If you're in a local context, like within the function, then those are private and they're not polluting the global namespace. Whereas if you use it like this in the global context, they're still polluting the global namespace. And the most annoying thing is if you do something like that in a function, you're defining a global variable again. So that is really something that you should never do. Like if you're, and that usually only happens by mistake. So within the function, you should always use the var keyword. You don't want to define a global variable within some function. So that I can't really think of a reason for doing that. Okay. Of course, you can execute operations on this variable. It's not very surprising. So I can define here. I'm declaring the variable sum. I'm assigning it the value 4. I can do the unary addition operator. I can do like the unary subtraction operator. I can do the self addition, as you know from other programming language, and so on. I can do division, multiplication. And so on. Any of the standard arithmetic operation, I can do modulo. So modulo essentially gives you the rest if you divide by the number. And you've probably heard of that modulo before. You can do a type of operator, which is kind of helpful in JavaScript quite often. So in this case here, we can see type of division, like this is returning a string of a number, and here we can see there's two ways of doing that. Like you can use it as a function, similarly looking to a function, but you can use it also like this. And in this case, the result is then assigned to type, and I'm logging the type. So we can see, okay, this is a number. And if I, let's say, type of test, oh, this is actually the one. You can see that's a string. Okay, so this is a very helpful operator that you will use quite a bit. And then you can do operations like string concatenation. Like here, I'm adding two words to each other, and I could simply look at the and you can see like here, this looks as a so we can now see that we have the string two words. One thing is that strings in JavaScript are immutable, so they don't change. They exist once, and if you do something like this, a new string is created that is made out of those two strings. Okay. Any questions about operators? There's a long list of other operators here. You should maybe take a look at them. So like there's binary operators, there is exponents, you can do shifts, you can do bitwise assignments, and so on. And then we will have the comparison operators that we will talk about when we talk about loops and control structures, arithmetic operators, and so on. So I've tried to put links to the documentation wherever it's appropriate.
Can you use hashtags to make comments?
No. You can use, like this is a comment here. You can use two styles of comments. You can use this, like it's Java or C style. You can use this style of comment, like the /* or the //. And if you use like just a side note, but a very convenient feature in many development environments is that you have these auto comment things, like you could do like block comment things with one hit. But you just look up your editor. That is very convenient to do. Like you don't have to do every single line by itself. Okay. Then we have arrays. We will be using a lot of arrays, as you can think, as you can imagine. Arrays are like a form of structured data, and in visualization we work with data, and there will be a lot of arrays that we will be working with. So there's a couple of different ways to declare arrays. So you can do it like this, or you can do an empty array, and then you can fill up arrays. So like here we can see the output. And as in most languages, like arrays are indexed at 0. So like if you want to retrieve the first element of an array, you have to like put here the square brackets of 0, and this would be the second element, and so on. So like in this case, we have 1 here. This is the number. I already mentioned that you can, but you should not use arrays of different types. So you can do this 0. This is true, unfortunately, and then you can do and then you can log this here like this. We have like we're retrieving the first and the second and the fourth element in this case, which is true, and this. You can access the length of an array using the length attribute. So like that's pretty easy. You can simply log the length like this here and assign it to a variable. And so one thing is that, for example, different from C is that you shouldn't initialize arrays with a specific size. So you should only dynamically fill them. So there is no need of like creating empty arrays of a certain space. Like you don't have to care about memory management yourself. You just create an array and you fill it up as you go. And it's actually and depending on your browser, it's actually faster than pre-assigning an array of a specific length. You can also nest arrays, which is something that we will also be using. Like you have multidimensional data. So here we have an array of arrays, and the lower level arrays have the length 2, and then in the upper level array we have the length 3, and then we can access them like this. So this is the first element of the second array, is 3. As you can see here. We can dynamically extend arrays by using the push function. And the push function returns the new length. So if you push something here, this also returns the new length if you need to use that for some reason, and we can here we can see the whole array. So the log method can actually log some more complicated data structures like arrays and so on. So you can quickly look at an array, and if I add another push here, see the push, not surprisingly, and again, I can do this. You can see that I have now a mixed array of integers or of numbers and strings. To remove the last element, I can use the pop function. And now you can see we're back to 4, so I can pop the string back off. So that works similar to a stack. And then of course you can do things like index off operations and so on. So this would return you the position of 2. You can log that. So you can see the position of 2 is also 2. Like if we were to and then go for index of what? You would find like what is at the end of the what is at position 5, so at the end of the array. Okay, so there's more to arrays, and again, MDN documentation. As I said, you will be using them a lot, so take a look here. This is a pretty good tutorial, and this will tell you a little bit more than I'm doing here.
Question?
Yes?
What if you had multiple whats? What is that going to return?
If you had multiple?
Yeah, if you had like search for what? The index?
Yeah, if it's going to return the first one.
Okay, first one.
Yeah. Any other questions? Okay. So you probably all are familiar with objects, and objects are the second type of compound data structure that we use in JavaScript, and they're also very important. So this is like the very simple way to define an object. So here, like we're setting an object to like the construct that is contained in here. Like we have a key 1 that is the number 3, and we have a key 2 that is the number 4. And then we can log the value. The value of key 1, the value of key 1 is 3, the value of key 2 is 4. So we can use this dot notation, which you probably know and which you're probably familiar with. But you can also in JavaScript refer to the members with like in this string notation. So like you can do object and use the square brackets to access key 2. This is kind of bizarre if you think in a Java or a C++ approach, but in JavaScript this is the way it's done. This is how objects are managed, and this also gives you immediately a hash table or a dictionary. Like this is the kind of the only dictionary or hash table that you will ever use in JavaScript. So like you don't have a specific hash table implementation, you just use the native functions of the object but for doing this. And then you can do also, like you can also define the objects using the string notation. Like here we have defined it without any of those quotes, but you can define them also in the string notation. And this now looks very much like JSON. And JSON is this JavaScript object notation, this data interchange format that is like very deeply baked into JavaScript too. And so we will be using this as well. And this is the kind of like how you would do definitions in JSON. And here you can see that this works equally, like the value of string key is undefined. Oh, because it's a string key 1. Yeah. So here we have 3, and then we have the one other interesting thing, of course, in JavaScript is that you can dynamically extend objects. So like in classical languages, you have to define all of the members of a class or of an object before you compile it. In JavaScript, you can simply add new functions or new members to an object at runtime. So I could say, like another object, new key is dynamically added. And then, of course, this now is part of this object. And that is powerful, and it can be misused. So I could, for example, override any of the standard implementations of array. Like if I think that array sort isn't efficient enough, I could simply replace it with my own sorting algorithm. And if I do that and other people don't realize that they're suddenly not working with the implementation they're expecting, then that could be annoying. So use this feature, and this is also, of course, the way how you work with hash tables. And as I said, you could easily do this with the string definition. But be cautious not to do things that people wouldn't expect. Okay. A number of basic control structures. I'm sure all of you guys have seen this before. You can do if conditions, else if conditions, and so on. So here we can see so this is another neat method, parse float. You will use that probably quite a bit too. So if 1 equals 1, then we get into the first if that is not true, and we get in the else if part, and we like the else if part is not checked, and if 2 is parse float of 3 is not true. So what happens here is we get the output here of the else. Pretty simple, works like everywhere. One little difference in JavaScript is that there's 2 types of comparison operators. So like this should actually be true. So here you can see first if, and that is something that you would not expect, like that the string 1 is equal to 1. There's one thing that you can do to avoid this. You can use this type safe comparison operator. So in this case here now we're in the else operation, in the else branch. So like this, the two equal signs just does a comparison and tries to cast it as best as it can, which is bizarre. And if you want to do a type-safe comparison, you should always use the three equal signs. So, like this is, of course, like in this case here, so that. This is, of course, now correct, because like here we should be in the else if. Oh. Yeah, so now we're in the else if branch. This is of course correct, but that's just because the parse float actually returns the number. So this would be how you should do it, and how it should work, but of course in JavaScript you can do it with just the two equal signs and it will automatically convert it. You have the standard ternary operator, so like the condition, question mark, what happens if condition is true, colon, what happens if condition is false. Like here we have 4 modulo 2 is 0, is true, so that means we log true here. And if that were not true, if we say 5 modulo 2, we would get false here. And this is an operator that you will see quite a bit in examples, and that you should probably be already familiar with, just to reiterate it. You can do switch statements. They can also be very helpful. In contrast to C or other languages, you can do switch statements on strings. So here I have some case and I'm switching over I. I have this case, the case string literal is okay, the case some case, and of course this is going to match here. And then we're logging unlike C. Then what is important is that these case statements, they don't break. So like if I were to remove this here, it would continue the evaluation. So what would happen here, or what happens here, is now that I'm also getting into the default branch. Like this is also similar to other programming languages, but it's important to note that, and that's like a common bug, something is happening and you don't know what, you forgot a break. So in a case statement, if you want to return after you have handled the case, you need to add the break here. And I also kind of mentioned the default statement now. So if none of the cases match, you have this default statement and that is executed if nothing else matches. Any questions about control structures? No. Great. Okay, loops. We have the familiar for loop, so we can like do this iteration the way we're used to from most of the other programming languages. So we can see the output of the for loop here is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We can do while loops, and while loops are essentially you need to take care of like changing the check yourself. So in this case, we're modifying I. You can see the output here is like we're continually multiplying I by 2, so 3, 6, 12, 24, 48, 96. And then you can do while loops, and do while loops are identical to while loops with the exception that they're always executed once and then the expression is evaluated. So in this case you can see do while loop does 3, 6 and so on. We've initialized it with 3 here. Okay. So now let's talk about functions. Functions are a very important concept in JavaScript and in any other programming language. So here we're defining some function as we expect it to be with some variable v. So we're evaluating v. If it's smaller than 10, we're returning v, and if else, we return v times v. And here, like we get what we expect. So like we're logging the function for 30 would be 900. The function for -5 would be -5. Like exactly as we would expect it from this function. But of course, JavaScript lets you do some strange things that are convenient sometimes, but confusing at some other times. So you can do some functions of the string of 50, and as you would expect now, we get the number 2500. So it tries to cast, automatically tries to cast the variables to whatever works best. Then if you do a string, like if you actually add a string that cannot be easily parsed to a number, you would get the result not a number. If you do multiple parameters for a function, it will just take as many as it likes and just ignore the rest. So like in this case, that just works. We get the result of 900. Yeah. And then if you do some function with no parameter, it assumes that you're using a default value which is undefined, and then you would get back not a number. So this is essentially what I'm telling you here is that you don't get a lot of compile time safety with JavaScript. So what you need to do is you need to test. Yeah, this can sometimes be bizarre, and these are kind of the more bizarre parts of JavaScript. So none of this code causes runtime errors. What did I want to see here? Oh, yes, scoping. Yeah, we talked about this. Here I have when I'm calling another function here, we have defined x and y within this function, and within this function they're defined, and then I can return a value. But of course, as you would hope for, and this is actually good, that neither x nor y, I cannot lock x or y here, so because they're not defined. So this is how you actually hide variables and stop from polluting your namespace. I don't need to put it, it's just going to throw an error. So here in this case, x and y are not defined, but unfortunately if I do that, we get actually the value of x. And that's not great. That should not happen. Of course, we should always use this var keyword to identify the functions here. Okay, and now we will see that this should actually just return. No, well, semicolons you can put them, but you don't have to, unfortunately. Maybe no, that's weird. Okay, so that should not work. Maybe this is a thing of my framework here that is not clearing the global cache, which it probably is. So if I reload the page, it should work. Okay. There is an alternative way of defining functions in JavaScript, and this is very important because this essentially brings you to the functional aspect of JavaScript, and it's like this. I can define a variable that has a name just as a variable, but instead of assigning it a number or a string or whatever, I can assign it a function. So okay, here I'm setting a variable to the name variable function, and then I use a function declaration. And you can see here I'm writing just like regular function code. If v is bigger than 10, I return big, and else I return small. And that works as expected. So you get the variable function of 30. Is big. What you can of course do is that you can later reassign this. So you can take this variable and then reassign it to another function. Yes?
Why would you do that?
What? Reassigning, or why would you do
Well,
that?
I guess, what's the benefit of being able to
Function declarations like that, generally? It's extremely powerful because you can actually pass functions as a parameter to another function. You can return a function. So this you will be typing this kind of like anonymous functions all the time. And for example, you instead of in many situations where you have to do asynchronous computation, you don't you provide a callback function, and like you simply pass along the function. And in D3 or you will a lot of the times you simply the second parameter is going to be a function where you actually apply a color or something like that. So this is this functional idea, which combined with object-oriented and so on makes JavaScript really interesting, and you can do a lot of things. But of course, if you're trained in an object-oriented language and you see some of this functional code, it's sometimes a little bit interesting. And you don't have to define you don't have to name these functions. So you can actually just here, instead of assigning it to a variable, you can just this can be done in line within a parameter of another function. So you don't ever have to hold the name for the function. Yeah, and as I said, you can pass them into functions, you can return them out of functions and so on. So this is a very powerful idea which needs some getting used to. So I would suggest that you look at that in a little bit more detail. And of course the reassignment here is just a consequence of that it is a variable, which is of course also dangerous, but you can do it. Okay, so now we can briefly talk about object-oriented JavaScript. So we have talked about objects, but we can actually do, we've only used them to hold variables so far, but we can actually do something like functions. So here we have a function, create object, that has a result, and the result is an object, and get here is a function that returns the content. So this is now an accessor. If you run create object and assign it to a variable, then you will actually have something like an object. You can retrieve the content and you can set the content. So you can set, with the set function, you can actually set content to a new value. And then you can do, of course, computations with it. So twice is a function that returns content multiplied by 2. So here we can play around with this. So first we create the object something, and then we get, we execute get on f, and of course, as we would expect, we get something. If we try to multiply something by 2, it's of course not a number, because the string is not a number. But then we can set 20 to f, and then we can actually retrieve it again. We can see, okay, it's actually 20, and then twice works. Okay, so this is how we can do object orientation in JavaScript.
So this content is just kind of added to that function.
Yes.
By being passed into it, okay.
Yes. So any question about the syntax? I guess this can be a little bit. So what we're really doing.
I guess you always have to pass it in. The functions have to be passed in, kind of assigned to a variable then, or how does that? Is that always how you're going to declare it?
That's how you should declare. There's 3 different ways of doing object-oriented ideas in JavaScript. This is one of the things that you could do, but I'm not going to go into the other ones. If you're interested in, this book has 3, discusses 3 different types in detail. Okay, and then we can do inheritance. And I already mentioned that it's a prototypical language, so we don't have any classes. So there is no subclasses. I can say this is a parent-child relationship on a class level because there is no classes. But JavaScript has the notion of an object prototype chain. So every object in JavaScript has one special member that points to another object. And typically this is just the global object, but then you can actually redefine this. So here we have a base class and a derived class, and we can log and the base version 1, we get the number 1 as we would expect. Then we can, the derived value is 5 as we would expect, and then derived v2 is undefined because the derived currently doesn't have a member v2. But then we can say object set prototype of derived base. So we can set the prototype of the derived object to base. And now derived has in its prototype the object base in it. So, and if it doesn't, like if the scope is, if there's no, yeah, so if you have like this variable 1 in this case, you can see that now we suddenly have the variable 1 of the lower scope, so like the local object here. Derived variable 1 is 5, but if we don't have if we don't have an issue with the scope, we can actually get the value of the object higher up in the prototype chain. So like this is declared, like if you have a lower level object and that defines a method or a variable of name A, and if I have like a higher level method like that it points to as its prototype, and it defines the name method, it uses the lower level. Like it uses the closest one at the bottom. So this is how you can do override methods, for example. But if you don't have that, it actually retrieves the method or the member of the higher level prototypical object. Okay, and that's how we get here v1 is originally of derived and v2 is of the base object. Any questions about that? Yes?
How is this different from using the new keyword?
It's the next example. Well, the new keyword, it's not essentially different. There is like the rule of thumb that the new keyword is one of those things that you shouldn't use too much in JavaScript. You can, if you use the new keyword, you can do like, this is similar to what I'm showing next, is object create. And you can simply, like, if you use a new keyword, you can pass a prototype. But in this case here, we just set it later at runtime. But you shouldn't really do this. Like set prototype is a method that typically, and it also says in the text here, that this is just for illustration here. But you shouldn't typically do that.
So would you, I guess typically you would just, when you initialize, derive.
Exactly, yeah. That's, yes, so you should not use set prototype off at runtime. This can just after you have used an object, this can just be confusing.
Right.
This is just here for demonstration purposes. So instead of using set prototype, you could use the new keyword, or you could use this object create method here. Like in here, I'm creating a chain of 3 objects, like I'm object creating, and the null here specifies the prototype object. In this case, this none. And here then we are putting v2 like as a child of v by using this object create variable, and then we can use like a second level of inheritance where we assign the prototype to be of v3 to be v2. Okay? Any questions about that? Okay, so the last thing I wanted to talk about today is the this variable. So let's take a look at this function here. So we have a function, another object, and then we have x, a value, then we have get a function, and we have set a function. And so here x is a value, and the idea is really that we can retrieve x, and then we can assign x to a new value. And to do that, we have to use the this keyword. And this is, like in many other languages, it points to the to the current instance. In this case, it's the scope of the function. And like here, we have like a value of x that is defined, and that means like we are really pointing to the x that is in the scope of this specific object here. And this works. As you would expect. So, like I'm assigning other, I'm creating an object, other object. I'm let's log that. So we can see that we have x here. We can then log the value here. Oh. So again, that works as you would expect. And it's like, yeah, one thing that I maybe didn't say yet is that you can access members of an object like this, or I actually did say that, yes. And then I could use the set here, and then let's see. We get the 5 here. And let's again the 5. So these are the 2 different methods, the 2 different ways we could use that. So this is how you would expect this to work. Nothing interesting here. The thing about this is that it is always relative to the object calling it. Like what happens is if I were to reassign this this get function to another variable, I suddenly would have a different this context. So here is an example for that.
Question.
Yes?
So for the previous function, what's the result for the other dot set?
Other dot,
Set.
there's no set.
The set pattern.
Oh, set.
Yeah.
It doesn't return anything. So like this is just, we're just setting a variable, like a value here. So like I don't return anything. I could, of course, like you could return X, but it doesn't really make a lot of sense. So typically setters don't return anything. Like maybe they could return a status, whether it worked or not, if you have something that is uncertain, but typically setters don't. So that's why I didn't log it, because it doesn't return anything. Does that answer the question? Okay. Yeah, so what we're doing here is we're using once a method and once we're using a direct access to X. So that is exactly how we would expect it to be. But if we do something like this, like here we have again a very similar function. Here we define yet another object, and then we should expect here the X to be 3. And then we see console log as expected of object.get, and this is fine. And then we assign object.get, the function, to another object, to another variable. And we can do that. Like this is the idea of functional programming. But if we suddenly plot the result of t without the context of the object up here, then we would suddenly get a different value. And here we get 40, which is because 40 is still in the global namespace from the early examples, but we could easily get not a number or undefined here. So what that means is this is always relative to the object calling it. And this is a kind of a bizarre artifact of the implementation. You typically don't want this, but you really have to take care that this doesn't trip you up at some point. So if you ever get any kind of bizarre bugs like that, you just should look at the chain of like, could your this be in the wrong scope? Okay, that concludes the class for today.
Question?
Yes?
Is this video being archived and we get access?
Yes, there is a link on the main page. So like if you go here, there is YouTube channel, and oh, there's a bug. Here should be the YouTube playlist, and I will put the link up right now.
Great, thank you.
Any other questions?
If you're working with like an IDE with this,
Yeah.
can you still get the output like you do with the console in here?
Yes, if you do it in an IDE, like in WebStorm, you would get like a console down here where you can simply. So what you can do is you can have the IDE open on one side, and then you can have the web browser open to debug. You can still have the console open, but you can also do things like debugging either within your IDE or within the Chrome developer tools. So both possible.
And is this WebStorm one kind of a good one to use? Would you not want to use one that's kind of like, you know, just text wrangler or something like
So
CS?
it will let you do a lot of things like auto-formatting code or like refactoring code and so on. I think if you're more productive using like something like WebStorm, and it will help you, like it will do autocomplete, things like that, text wrangler, and all like much it can do. WebStorm can do much more. It can automatically deploy stuff. It automatically can run the service for you, and so on. So I like it. You don't have to use it if you can.
Can you do like Python and stuff?
They have PyStorm, which is the, this is all very similar. It's